Okay, so welcome to the session. So we have Yulia and Dimitri from IBA Group, and they're going to be talking to us about DevOps for DevOps. Sorry about the slow start today. We've had a few technical difficulties, but we're there now, so hopefully everyone's happy. Please do remember to leave session feedback as well. The session is 5BA. And please ask any questions you've got in the group chat. If you click on the chat button at the bottom, you'll get a chat window that you can ask questions in, and I'll ask it to the speakers at the end of the session. Okay, so thank you. And with that, it's over to you guys.
Okay, thank you. So let's get started then. My name is Yulia, and I would like to talk a little bit about DevOps for Z, and how do not forget that DevOps engineers also need DevOps help for themselves.
Hello, my name is Dmitry, and I believe that mainframe is not so far from the real DevOps.
Okay. So let's talk about the following point and make sure that you're in the right Zoom room. I would ask you to answer on several questions just for yourself. If you can answer on at least one question, yes, so you're in the right room. And do you have a DevOps department section, or at least DevOps secretary, or maybe do you write DevOps word next to each your tool or script or project or your presentation name? Or did you saw this nice picture with infinity scene? You remember code, build, test, deploy, release? Maybe did you have a discussion with someone one time that DevOps is not about tool set or about some system administration, it's about culture changes, company transformation, and agility of software development. Did you see Jenkins or Urban code at least once? Or do you know a bit about CI, API, CLI, or CD? Does your CV start actually from DevOps engineer world? Yes, you're right. It was just for fun questions, and all of you in correct room, and we are ready to start our DevOps journey. So as we told, we are from IBA Group, the company with more than 25 years of experience in application development, and in the most cases involved in Z platform. And our slogan is engineer trusted and customer-centric solution that bridge the legacy of the past with the landscape of the future. It's real true. What we do in our day-to-day work, we build CI/CD pipelines for more than 30 teams who develop their Z code and the applications. Our goal is rapidly and with the good quality shipment of each Z story to the production environment. Application which our team developed contains some logic part, usually it's C or high-level assembler or Peer 1 or COBOL code, included batch applications for theory workload scheduler and Java application, especially if we have web interface, but on Unix part of mainframe too. It also DB2 for Z, MQ, and CICS. We are preparing pipelines for ETL applications development, and we built one push button solutions and pipelines for IBM Infosphere data stage projects too. We are not familiar with that tool. We are really familiar with all tools presented on this slide. You could see some of them on the left and some tools and technologies on the right. What's in between is our pipelines. As an engineers, we have to play with all technologies on the left and combine them and use everything you see on the right side. On this slide, we gather our technical solution in one place. And at the high level, try to combine how our solutions work with zeros code and distributed, including different functionalities. Our team prepares unified CI/CD for the cross-dependent squads with application components and different application components, and very complicated and completely different. We select the IBM Urban Code Deploy tool as a main integration tool. We actively use plugin for GOS. It's available in UCD plugin store. There is a main advantage for us because for some deployment needs, we have to play with US artifacts, and there is a plugin we are working with. It's not something which works via FTP file allocation or Zoe or DSMS thing. It's something completely different. Really, you see this big amount of functionalities available in that plugin, and we can play with mainframe artifacts using this. There is a slide on slide also our server's architecture, where we have our client server urban code application running somewhere, and also we've got an agent of UCD installed on different platforms we have to play with. So, and just a joke, actually I found it in one of our development charts. Well, Jenkins on virtual machine, it's everywhere Jenkins, and urban code is yes, no docs, and immediately difficult. I would say that it's partly true because sometimes it's quite difficult to find some docs on some plugins, etc. But from the other hand, it's really cool tool to use as an agile for our CI/CD pipelines. So some features on how it works. So we use Bustool utility, which help us to connect our mainframe ZOS artifacts with our client server UCD. When I say UCD, I mean Urban Code Deploy application. So Bustool is a part of UCD agent installation, which works as an address space on mainframe and stored on the Unix part on mainframe. And when we have to put some mainframe artifacts, as you see on the first picture, we just have to create this nice ship list file in XML format on the Unix part of mainframe. And then we are running some shell scripts, and you can see on the bottom, we could connect our artifacts and send them to the UCD server. So here we call this shell script from GCL, but it could be called wherever we want to do it. So back to the architecture, current pipeline that we have now is the ability to use, as I said, the mix of different operation system as a sources, version control system, application management system, test frameworks, depending on your business needs. We adapted the solution corresponds to team existing toolkit and technologies. So let's start from development part of this. And development, as I said, it could be PL1, Java, C++ program on mainframe. Here it can be DB2 database functionality and another MVS distinguishing features. Together with that, you will need to deploy some code developed on Windows or Linux, for example, platforms, or some data stage IBM InfoSphere data stage code for ETL processing. Commonly, after the commit, developer initiating the pipeline start process on native system for the developer. We provided such a script to initiate our pipeline start from any kind of platforms for the developers. It's like a button. So developers should just run some script to initiate all magic we prepared for them. And as you can see on the slide, we also prepare such a documentation, how to initiate this pipeline start. And of course, natively it should be done for some system after the commit and automatically, but for the mainframe artifacts, yeah, we prepared such a script also in case you have no Git installed on your mainframe platform. That's why this example is here. So addressing to the agile for our technical solution, we have our code station, so the code artifactory. When we store out our code in CodeStation, it means that it was ready and prepared for promotion, and also we see some meta information about every version we created and prepared to the deploy. So after developer initiate our pipeline start, the idea is that using the Bustool utility, we send an artifact from the mainframe to that web server, right? And all meta information about the version, also with some like the latest date of updates and who created that version, all of this information are available in our code artifactory called CodeStation. So during the deployment process, we perform, of course, Jira or RTC item status handling to document all steps. It's important part of work when everything correlate. I mean, what is going on with your pipeline and how your story is going through all of these, for example, Jira workflow. So, for example, deployment to test environment will be started after setting Jira status to ready to test installation mode. And we are preparing really a specific Jira workflow for our team and for team we support to make it visible for all. Sometimes we have to adapt or create our custom workflow. It's really work of DevOps engineer how to suit this for everybody needs. Yeah, and UCD process, of course, can set all statuses and changes automatically in Jira, populate some fields, update the story, etc., etc. So just documentation part on every stage. And installation on mainframe test system by open code process consists of many steps, of course, including some environment preparation, code customization, and deployment itself with some mainframe magic. Relatively distributed code, we promote code to the test system and do appropriate test machine, and that's it. Nothing here. But after the deployment, and complete deployment with all needed customization, etc., we usually run our test suite from rational quality management or test trail. It depends on quality management tool your team using. But QA team prepared their test automation suite in advance and before the deployment. Test frameworks also not the same. Each application select language and test frameworks suitable for their needs, but meta information are available as pipeline execution variable, and we can perform our test automation run exact after the test installation. So you remember this the first picture in our Bustool ship list. So in our XML file here, actually we store this meta information about what test suite should be executed after deployment on test system. Our feature that we developed, that test suite also covered automatic code review. At the same time, also here we created some scripts to prepare automatically test data preparation, test runs, test automation itself, and test running some tests to test business logic too. And the feature here is using also our automatic code review model. So according to your team architecture requirements, we prepare like custom code to check something. So we have really a list of checks and code review, and we have a list of such a project realized. And how it works, for example, we could check the isolation level for your DB2 queries. And in case it's something that you are not expect, we could return your code back, etc. So it's hard and difficult to find some tools and some technologies which could automatically cover somehow the mainframe code and especially the DB2 changes, but we have to, so that's why we created our frameworks for the test automation and also our code review model, our own, to execute all of this stuff because it's important in our current reality. So how we do our solution so flexible and adaptable for 30 teams. We map inside of our scripts all of our custom setup for different teams. Something like a dictionary we use or the hash map for all of supported projects. So the idea is to use and support many teams via one solution. Of course, this requires additional team effort to add some new team inside of our big pipeline. But as I said, we are quite flexible. We have these hash maps with mapping all team with all their meta information, and so we could use our one unified solution to promote the code between environments for different applications, including different functionality. Just think about it, because it's quite hard and difficult to support many pipelines for every team, but our team is supporting just our own, and it's better work. And yeah, also our team spends some time for supporting this and replying question, of course, but it's how it works in our reality. So actually, also we're trying to use maximum of plugins possibilities inside of Urban code just to do not create the custom code. But as I mentioned, it's quite difficult for sometimes to find something suitable for the mainframe application. So here you can see a small piece on the right side of unified pipeline prepared for development between the 7 scope of servers through the dev, test, and production environments. And on the left side, you see these blue cubes. We call it for each tag feature. And it works like the cycle for infrastructure and for deployment happened not only on one servers, but on scope of servers marked by specific tag. So for example, this create version could be run on 7 servers in parallel using this UCD for each tag feature. So you have just one step in your pipeline that there will be a cycle inside, and you could repeat this action on the scope of servers. It's quite important. So yeah, we have to share with all the teams how to work with our pipelines and bringing our processes to common in our organization, as well as a lot of trends and documentation. So we spend a lot of time on workshops and trainings with our team we support, with our automation, and trying to explain them new feature and collect the feedbacks. We have to improve our pipelines. So actually, our documentation much more informative than you could see here. Well, and there is an Amazon help, and we try to find here some information how to order something, but I don't know, it was a bug or just a problem for some times, but really our documentation is much more informative. For example, our user guides about our own test automation framework, it's much more than 70 slides created in a user guide mode. So we try to make it easier for our users how to do this or that stuff. And started talking about DevOps for DevOps. We feel the needs as an engineers to automatically enter a new team into our processes and do all necessary registration automatically. Our team also prepared a large amount of code that must also be assembled and delivered to all necessary environments. We also have development, test, and production when we build our pipelines. So, and really, we just imagined one time that we have to create DevOps for ourselves. So same requirements here. Our code also required version control system, I mean DevOps engineers code, and it also required test automation for that. And this is one of reasons we start reflecting about DevOps of DevOps. So back to architecture, we just need to finish. Installation and production system by urban code processes take place at a scheduled time. It has the ability to be repeated several times in case of infrastructure problems. Why on scheduled time? Because in our reality, we can't just deploy it at any time. It's usually some time frame window. We could implement changes on the environment. So yeah, we realize it all on all this scheduling functionality. And we included, of course, Slack notification to inform all dev team and stakeholders about all supported pipeline steps and how it's going through all the stages. And very important thing, it's integration with Grafana or PagerDuty for monitoring and alert purpose. So the architectural schema lacks very important roles related to automatic rollback from the different stage. In case of failure somewhere, we need to automatically roll back our code and return back to developer. During the deployment process, we create several versions of not only the source code, but also infrastructure and application level backups to have a chance return everything back. Actually, it was, I would say, the most complicated task to save infrastructure state and to prepare full backup feature. We faced the problem here from time to time because it's really difficult and new situations appeared when we didn't take something into account. But again, we tried to have such a feature to roll out everything back in case of problem at any stages. So if you correctly understood my previous story, you have a DevOps squad, dedicated DevOps squad, which works with many teams. This is an adaptation in our organization to current realities. We know that in vanilla agile and DevOps and DevOps engineer must be a part of agile team. But in our organization, we decided that one team have to support on this at all DevOps features, all of this list of the teams. We have our own backlog and our own product owner, who is one of the leaders, I mean, like the delivery manager inside of the company. And our lead is interested in rapid customer satisfaction and quality of code we promote to production. So we have our own backlog for the DevOps code and our own stories for the new features implementation or bug fixes too. And we have like 1 month iterations for our team because our iterations quite a bit longer than usual application team. It works and it suits for our team goals. And we using something like a Scrumban. We track our bugs via Kanban, and we using the Scrum board for providing new features. So, and again, I would highlight that you remember this agile manifesto phrase, like working software over comprehensive documentation, but for our team, it has the same importance. Because all of the team on the right side here has their own backlogs, their product owners, and they all try to use our pipelines, but we are like trying to deliver our value for all of them. And in our case, the documentation is quite important, because in case somebody from the team we support don't know how to use some steps of our pipelines or why something broken, we will just reply in a Slack all the day and we will have no time to any development. So in our case, clear documentation, how everything works, what requirements for code review, what requirements for test automation suite, what to do in case something fails. It's only one way how it could work. So our team prefer approach infrastructure as code, as Dmitry will talk you in the second part of presentation, but let's see the problems and challenges we faced during all of this structure I explained. So team technologies, stack and infrastructure differences inside of one organization might be a challenge. Of course, a lack of time and resources for ourselves, for our DevOps automation. It's really quite tricky that we provide a DevOps solution for many teams, but sometimes we have no time to DevOps ourselves. Version control system for DevOps processes. It doesn't matter you writing scripts for Urban Code Deploy, for Jenkins, etc. Everything, I mean, your Groovy scripts, everything should be stored somewhere in version control system. Just remember that. And testing of DevOps processes, of course, it's also difficult when you have a big pipelines which support many teams. It's quite a challenge to test everything, to test all combinations, rollbacks, etc. That's challenges we've got, and what ideas we have to solve those challenges. We just call it DevOps as service, infrastructure as a code. Again, Dmitry will talk you in details how we're doing it. Clear documentation, one way for us, how everything could work. Then pipeline testing. We have to test our pipelines properly before we deliver it for the team usage to our production, and education sessions and workshops on regular basis to the team. So in our case, our customers, it's equal to our application development teams, and we provide a demo to them to share how the new features implemented in pipelines and how everything works is important. So summarizing the above, we are following two concepts. Again, DevOps as service and infrastructure as code. And on the first step, we need to, as a part of DevOps as service and how to include a new team, for example. On the first step, we need to research the customer environment, the environment of the team, technologies, infrastructure, toolset, platforms, and challenges. We have to talk to them. Then plan and propose based on application team specificity, how to include them in our unified solution. And actually, here is the work from both sides, because sometimes it requires some adoption from application team too to be included in all of these automatic deploy magic. Also, approve the approach by the team lead usually, or by product owners or stakeholders of the team we are going to include inside of our pipelines. We have to have access to team infrastructure, of course, and set up all required connections in advance. Then we enable our CI/CD one push button pipeline usage for the new team. So test pipeline, how it works. Then it's new features. New features could be expand some pipeline functionality based on requests or feedbacks of the team we support. It could be change or upgrade the tool set. Sometimes somebody told us that, okay, we are not going to use this tool, we are going to use another, and we have to adapt our pipeline to play with a new tool set. Also, unify for other team usage or reconnecting to another platform. It became, I don't know, a flash mob to move everything to cloud. So now we are reconnecting everything to cloud platforms, to new operation system, etc. So, and providing education session, of course, and again and again, and consulting at all stages. It's our engineering depth. And I think Dmitry will share with you some information about usage infrastructure as code in our reality. And yeah, Dmitry, please.
Hello, everybody. Thanks for joining our session. And I propose to start from a little joke. Yep, sad but true. Why is it true? Because that's typical DevOps trouble. Every DevOps engineer thinks that he got DevOps, but it's not true. Why? Because most of DevOps thinks that DevOps is only about developers, testers, and operations, about processes, about pipelines, about metrics. But they forgot that DevOps is firstly about peoples and teams. And they forgot that DevOps engineers are part of teams too. Also, I don't know why, but in most cases, DevOps is also forgot about system administrators. What does it mean? First of all, I saw many DevOps who automate work for the other team members, but forgot about automation for themselves. Then what should we do? Let's automate everything. A typical task for our sysadmins and previous DevOps team is cataloging remote databases on our service. Usually it took hours of or sometimes days of work because sysadmins took backup of DB catalog on servers and create scripts and run this script. After that, then they contact our users. Users should run some UAT tests, then send feedback and repeat all these steps in case of failed tests. Users and developers wait too long. Now it looks like admin fills all needed fields from in process screenshot. Only needed fields, current DB catalog list automatically backups, then automatically create and run script. After that, it's automatically notify user fill credentials to test connection. And in good case, process ends. In bad case, process automatically roll back connection and generate report. Looks better, I think, right? But this is just a little example. But what we can do with, for example, if we need to update Java or DB2, remove some software from the server, how we can automate it, how we can test it, and why we need it. Here, infrastructure as code. Infrastructure as code can help us with it. Infrastructure as code is a management of infrastructure. I mean, networks, virtual machines, load balancers, and connection topology, and many else things in a descriptive model using the same versioning as DevOps team use for source code. As I think, infrastructure as code, IAC, sorry, is a key DevOps practice. Infrastructure as code evolved to solve the problem of environment drift in the release pipeline. Without EAC, teams must maintain the settings of individual deployment environments. Over time, each environment becomes a snowflake. That is a unique configuration that cannot be reproduced automatically. With snowflakes, administration and maintenance of infrastructure involves manual processes, which were hard to track and contribute to errors. Imagine you have 10 years old project with millions users and hundreds of people have worked with this service across the years. This is how your dev server looks like after 10 years. Just a little cute penguin. This is how your test servers looks like. And this is how your prod server looks like. I know it seems similar, but it's not true. Okay, I think now you understand why the infrastructure as code you need in your project. But some of you can ask, I don't care about my teams, money first. Why I should use infrastructure as code? Why I should test an infrastructure in my business? Just an easy answer. This unlocks the powerful ability to test your infrastructure just like you test your code. Major code bases contain many unit and integration tests to verify that the code logic is correct. Those tests also protect us against logical regressions, where new changes cause old things to break. Infrastructure as code unlocks the same ability with your with your infrastructure too. Your administration never need to worry that the web server won't able to connect to the database. Why? Because they can take a few minutes to automatically build a new instance of the product and confirm it works to specification. This eliminates the bad news that something wrong, something isn't working right after the update. Instead, you will be able to deploy with confidence that your systems will work as expected. Your developers and administrators will experience less stress, and your customers will be happier with fewer bugs and more frequent features. Happier developers, happier customers. It's mean better business, more money. About technical stack, in our project, we mostly for testing our infrastructure, we are mostly use for distributed systems is OpenCode deploy for our to configure our environments automatically, to run our test. For tests, we use Bash, we use Groovy, and sometimes we use Python. And of course, Jira for tracking issue automatically. Absolutely the same for ZOS, but for ZOS we don't use Python, Groovy, and Bash. We use GCL and Jira for tracking issues. Okay, imagine this ship is your project. Let's name it mainframe Titanic. This picture illustrates how unit tests works. And yep, in this case, all unit tests passed. This is a little example of our simple example of our unit tests. I choose this sample just because I hope that all of you can understand what you can see now. This is an example of unit test for Linux system. In this case, we just check is the Java installed on our Linux server or not. I think it's a critical case in most of projects, but sometimes sysadmins forgot to, for example, change path variables or something else. I'm sorry. And a little sample for ZOS system. As Yulia told, we work with our customers use TWS, and sometimes we need to update this tool. And after updates, we usually run tests. For example, in this test, you can see that we check the subsystem specification, ID definition, and ID some specific setups tests. Okay, I hope you got it. Now let's talk about smoke tests. After every maintenance deploy, we run smoke tests, and our service becomes smoke. Okay, absolutely simple test for the distributed systems. Here we know, as in smoke test, we know that Java was installed, but we need to check the version. We need to check vendor or many else. But in this case, we check the version. And for the OS, sometimes we need to deploy some our tables, our technical DevOps tables. And after every deploy, we run this kind of job to check is deployment was correct, is all objects in place, and is content in place after deploy. And the last type of tests which we use is regression. For regression test is mostly not for our infrastructure. It's mostly about our pipelines, because I think we need to test pipelines too. After every pipeline update, we have a chance to get a regression bug. And to avoid these bugs, we have versions and tests to check if something was broken or not. In the end of the day, for example, you can see this kind of version for ZOS regression package. In the end of the day, we have a project where everyone is interested in DevOps principles and good cross-team communications. If you are a businessman, please think about your workers and your money. These techniques will save your money in future. If you're a DevOps engineer, please do not forget about your sysadmins and, of course, about yourself, because we are all of humans. We make mistakes. Automate and test everything that you can, and make your project great again.
Okay, Dmitry. So finally, DevOps for DevOps, like and right, it's very important. So to the DevOps in yourself, we just realize it and try to share it with you. But what else? Code review for code review. For us, it's also a case because we created an automated module when we create some checks for the teams, and it's actually written on Java, and we maybe have to use some kind of code review for our code review, right? So code review for test automation. What does it mean for us? It means that also for tests we create, or even for test framework we create, we also have to have some such kind of code review. And finally, tests for tests, of course, and for sure, who are testing our tests and what we verify actually. It's just the little things we try to share with you and to think about that we can't stop on automation. Of course, it's quite difficult to reach the goal of 100% of the automation, everything we understood it, but our direction is to automation as much as we can and automate as much as we can. So, and yeah, that's it from us. Thank you. And question, please. And here is the slide you have to put here about the session feedback.
Thank you very much. So you do have a couple of questions. We've got, as you start developing your pipelines, what are the key metrics you focus on to measure your ongoing improvements and success?
Okay, so first metrics for us is our users' feedback, right? Usually everything we developed based on user centricity. So we are going to user and asking them what was done right, what's wrong, and what we have to change. And actually our backlog prioritized just on the needs our teams have. So As I said, our customers, it's our application team we support with all this DevOps pipeline. Its key metrics is just, I would say, like happiness of our users. Of course, we are tracking to like our team velocity and how many features we can deliver during the sprint, and also we are tracking the amount of defects and our test depth and backlog, as I said. So we have so too, and sometimes our users would like to have a new features in pipeline, but we know about tech debt, and we say just no, not in this iteration, it will be fixing some major bugs. So stuff like that, it's like in any usual development, we are tracking bugs, how long these bugs presented and what, and also, but in most cases, yeah, it's just the user centricity and something based on the feedback from the team.
Great, thank you. And how are you provisioning data into your test environments?
Okay, we have the feature called test data preparation, right? And in our case, it's a kind of custom code, or using some IBM InfoSphere data stage features. We populate, for example, some DB2 tables on our test system. It's IBM data stage information server. It's a kind of ETL tool which could unload some data from somewhere, even from some docs or from boxes, from cloud, from another table on DB2, and load to your test system. And we're using this tool to promote the data if we are talking about data volumes, you know, but it's also sometimes for if we are talking about testing our technical things for our pipelines, we could create the test data for ourselves. In case we have to test like all combinations or something, etc., etc. We are preparing, as Dmitry showed, regression packages with all information inside, just for ourselves to test, or to test all possible combination of everything. But if we are talking about a mountain of data, we are using, as I said, this IBM InfoSphere data stage mostly for populating data on the system.
Great, thank you. And that's all the questions that we have, unless anyone has anything else that they want to put in the chat. But otherwise, I think we'll call it a day there. So thank you, that was really interesting. Everyone, please do go and give feedback. So it's session 5BA, and we need all of your feedback in by the end of today so that we can collate it all and give prizes for best speakers and things like that. So yeah, thank you very much. And with that, I'll end the session. So thanks, bye.
Bye.
Thank you all. Bye.